In today's topic, let us discuss about the difference between a contactor and a relay. It's a very basic topic but a very important interview question asked in most of the electrical interviews. So, if you are interested in more such interview questions or electrical related topics, please subscribe this channel for more videos. Now, let us not waste any time and quickly jump back to our main topic. Surprisingly, the working and operation of a relay and a contactor are same. Both are electromagnetic switches which are used in making or breaking the power circuit. The word electromagnetic switch is very important, and the word making and breaking electrical power circuit is also important. Both of them are electromagnetic switches, that is, both a relay and a contactor works with an electromagnet present inside it. The electromagnet present inside both relay and contactor is a coil wound and an iron core. That is, if you see, this is an iron core and there will be a coil wound on this. This is the coil and this is an iron core. So, if you provide supply to these two terminals, a field is created in this and this iron core acts as an electromagnet. This is the basic working of a relay and a contactor. Till this point, we have understood the working of both relay and a contactor. Now let us see the difference of a relay and a contactor. These are the basic differences of a relay and a contactor. The first difference is relays are smaller in size, whereas contactors are large in size when compared to relay. Relays are operated in low voltages, a very important point, and contactors are operated at a high voltage circuits. A low voltage means generally the voltage of a relay up to 250 volts AC, and a high voltage means the voltage is up to 1000 volts AC. This is very important points. The 250 and 1000 volts are very important terms. It is used in control circuit and contactors are used in power circuits. As they are operated on low voltages, these relays are mostly used in control circuits, and as these are operated on high voltages, they have high power switching capacity. So they are used in power circuits. Relays are generally rated at low ampere rating and contactors are high ampere rating devices. Low ampere rating means the maximum current rating of relays are up to 20 amps. These 20 amps relays are known as power relays, whereas generally the basic relays are rated below 10 amps. So if an equipment is taking more than 10 amps, will shift to an contactor, whereas the ampere rating of a contactor is up to 12,000 amps. If any equipment is drawing above 10 amps, we will shift to an contactor. The next point is a control relay consists of at least two NO-NC contacts. You will understand if you look at the internal diagram of an relay. It looks something like this. This is the coil and you have an NO contact, an NC contact and a common terminal. This is common and this is NC contact and this is NO contact. So basically you have two contacts. These two are fixed contacts and this is a movable contact. The phase is connected to the common and will shift between NO and NC contact. So basically in a relay you have at least two NO-NC contacts, NO and NC contacts. If you see a contactor consists of minimum one set of three-phase power contactors, and in some additional cases a built-in auxiliary contact are also provided. Basically in any contact we have three power contacts. These three are connected to the supply and these three are connected to the load, and these are the contacts. These three are fixed contacts and these three are movable contacts. These are the minimum set of three-phase contacts a contactor has, and in some cases we also have additional NO-NC contacts. Next point is relay often are both normally open and normally closed contacts depending on the design function. So In a relay, you have both normally open and normally closed contacts. So according to your desired function, you can choose either a normally open relay or a normally closed relay. That is, in a de-energized condition, if you want a relay to operate as normally closed, you have a normally closed relay, and in a de-energized condition, if you want that relay to operate in normally open condition, you have a separate relay for normally open condition also. So as soon as you give power, the normally open relay acts as a normally closed, and the normally closed relay acts as normally open relay. But in a contactor, mostly normally open contacts are only provided. I'm talking about the power contacts. See, these three power contacts are always normally open in de-energized condition. Whenever you give power to these three contacts, that is, whenever the coil gets activated, these normally open contacts changes to normally closed. So basically, in a de-energized condition, contactors' main contacts are always normally open. The seventh point and last point is a very important point. That is, in a relay, we does not have an arc suspension chamber, whereas in a contactor, we have an arc suspension chamber to quench the arcs faster. As relay are operated at a very low voltage, that is less than 250 volts, we does not require an arc suspension chamber. On the other hand, contactors operate at a very high voltages, so they required an arc suspension chamber to quench the arcs faster. That's all for today's video. If you like the video, please do like, share, subscribe my channel. If you have any doubts or if you need any topic to be covered, please do leave a comment in the comment section. This is Sandeep Shatri signing off.